Okay, number 2 here. On the Integrated Math Unit 6A Study Guide, question number 2. Given, this is the arithmetic sequence, given two terms in, this thing was flashing, never mind. Given two terms in an arithmetic sequence, find the common difference, the first term, the explicit formula, and the recursive formula. Okay, so the two terms that they gave us, here we are, question number 2, and the two terms that they gave us are A15 equals a negative 58 and A34 equals a negative 96. Alright, so the first thing we're going to do is common difference. So step 1, common difference. And then what we need to do is we're going to get the value that's between the steps of the sequence A15, 16, 17, 18, 19, all the way up to A34. That's the same value for each step of the way. So the first thing we want to do is take the values of A34 and A15 and find the difference. So we're going to go A34 minus A15, and then we're going to divide that by the n value, corresponding n value. That would be 34 and A15, 15. So this is the actual value, and we're going to go minus 96, and we're going to subtract a negative 58, and we're going to divide that by 34 minus 15, and let's just use a calculator here so we don't make any silly mistakes. And we have 96, a negative 96, and we have a negative 58, and we're going to subtract, and that gives us a negative 38. And then we have 34, subtract 15, and that's 19. So we have 38 over 19 for a common difference, and 38 divided by 19 equals 2. So we have a negative 2 for our common difference. So I'm going to say here D equals a negative 2. We're almost there. So the next thing we want to do is find the first value of the sequence. So this is the 15th value. This is the 34th value. The first value would be A1. So we're going to go, next thing we want to do here, step 2, is we want to find A1. Now we have the equation, and that is AN equals A1 plus N minus 1D. So we're just going to use this. Just plug and chug some numbers. All right? So let's go ahead and write that down. We have AN equals A1. I should have made that N a little smaller, but that's fine. Plus, just copying what's there, N minus 1 times D. All right? And so then let's go ahead and take, for AN, let's go ahead and use A15 here. Okay, so A15 equals a minus 58, and then equals A1. And then the n value for A15 that comes here is 15, right? So it's 15 minus 1 multiplied by d, which is a negative 2. So this is just math. Let's not get bogged down with it. All right, it's pretty easy, simple algebra. Negative 58, we got that A1, and we have 15 minus 1 is 14. Oops, plus. Sorry about that. Plus 14 times a negative 2 is a negative 28. So plus a negative 28. All right? So let's add 28 to both sides to get rid of that. See, a negative 28 plus 28 is going to be 0, right? So we're gonna add 28. I want to get this by itself. Plus 28. And we're going to go plus 28 on both sides. So 58, or a negative 58, and we're going to say 28 plus, that is a negative 30. Negative 30 equals A1, and so that is our value. So that these two cancel each other out, left with A1, and so we're done with that. We've got our A1 value. Yay, yay, yay. So now what we want to do for our explicit formula is we're going to use that same equation, all right? Explicit. And we're just going to take AN equals A1 plus n minus 1 d. That's that same equation right here, okay? And then we're just going to kind of, crunch it out. So let's go ahead and put in our value for A15 here. Okay, that's going to be our AN. So we have a minus 58 equals an A1, a minus 30 plus, and then that we have a 15 here, right? So that 15 value minus 1, and we're going to multiply that by d, which is a negative 2. So we have minus 58. Oh, wait a minute. Sorry. You know what? Yeah, sorry. We don't want to do that. So let's see here. I'll have to edit that out. So for our explicit, we have AN, equals A1, which is a negative 30, plus n minus 1 times a negative 2. And we have AN equals a minus 30 plus a minus 2n. I'm just going to minus 2 times n is a minus 2n. And then we have a minus 2 times a negative 1. Negative times a negative is a positive, is plus 2. All right. So we have AN equals a negative 30 minus 2n plus 2. And a negative 30 plus 2 is a negative 28. Negative 28 minus 2n. And that is our explicit formula. So now for the recursive, okay, recursive formula, we just kind of like the recursive is what a n plus 1 is. It's like, hey, if you have, something like a15 and you want to know what the next thing is, remember they're all separated by the same amount, okay, and that's d. So each of these, a16 is a minus 60, and then a17 is a minus 62. It's just minus 2 with minus 2 until we get to a34 with a negative 96. So for the recursive, we want to put a n plus 1. N plus 1, don't get confused about that. That's just the next one. It equals, like, anywhere in the sequence is a n. A n plus 1 would be the next one in the sequence, right? So it's just going to be, in this case, taking out a negative 2. So, like I said, if a15 here is, then we know n plus 1 would be a16 is a negative 58, right? Minus 2 is minus 60. So the recursive formula is this. Okay, so I'm going to scan this. Sorry for this little mistake. I'm looking up at the screen, I'm writing, I'm making sure everything's being filmed, and I just got a little distracted right here. Otherwise, if you study this pattern, and even if you did these two problems like over and over again, like 3 times, and then maybe another one that you find or something, you'll get it. All right, and then you just follow this pattern, and you can just bust this out and nail this one. Okay.